So first it wants to know, when does the ball strike the ground? Well, the ball will strike the ground when its height is 0. So to figure out how long the ball is in the ground, we're going to set the height equal to 0. And remember, the height is the S of t equation. So it's going to equal negative 16t squared plus 80t plus 96. Well, we can factor this. We can factor out a negative 16, and we would get t squared minus 5t minus 6. And so this would factor into t minus 6 and t plus 1. So the ball will be at a height of 0 at time equals 6 and time equals negative 1. So that means that after 6 seconds, after 6 seconds, the ball will hit the ground. At what time t will the ball pass the rooftop on its way down? Well, I apparently didn't include the picture for this problem, but here is the picture for this problem. So we have somebody standing on the rooftop and they throw a ball up in the air, and then it's going to make that arc, so the parabola looking shape, and then it'll eventually hit the ground, and it'll hit the ground after 6 seconds. But we want to know when the ball, after it's thrown up, will reach the rooftop height. Well, the rooftop has a height of 96 feet. So we want to know, when will the ball have a height of 96 feet? So we're going to set the equation, the displacement equation, equal to 96. So 96 equals negative 16t squared plus 80t plus 96. Well, if I subtract 96 from both sides, I would get 0 equals negative 16t squared plus 80t. And I can factor out a negative 16 from both of these, and I would have I could factor out a negative 16t from both of these. And I would be left with a t minus 5, so either t equals 0 or t equals 5. So after 5 seconds of being in the air, the ball will be back at the same height as the rooftop, or 96 feet high. What is the average velocity of the ball from 0 to 2 seconds? Well, remember to find average velocity. It's going to be change in displacement over change in time. So we're going to do the displacement at 2 minus the displacement at 0 over 2 minus 0. So we're going to plug in 2, and so we're going to have negative 64 plus 160 plus 96, and then minus plug in 0, and we would get 96, and then all over 2. And so we would get 96 minus 96 goes away, and then we would have 160 minus 164, which would be 96, and 96 divided by 2, so this would be 48 feet per second. So the average velocity of the ball between 0 and 2 seconds would be 48 feet per second. If we want to find the instantaneous velocity, that's when we're going to use the derivative equation. And so for part D, to find the instantaneous velocity at any point t equals 0, we would want the limit as t goes to t sub 0, and then of f of t minus f of t naught, or t sub 0, over t minus t sub 0. And so f of t is our original equation, so negative 16t squared plus 80t plus 96. And then minus f of t sub naught would be negative 16t naught squared plus 80t naught plus 96, all over t minus t naught. And so if we distributed that negative sign, we would get negative 16t squared plus 80t plus 96, then plus 16t naught squared minus 80t naught plus 96, all over t minus t naught. And that's the limit as t goes to t naught. All right, I'm going to add a page to have more room. And so now it wants to know, what is the instantaneous velocity when t equals 2? Well, that's going to be the limit as t goes to 2 of f at t minus f at 2 over t minus 2, or this is going to be s of t. So this is going to be the limit as t goes to 2 of negative 16t squared plus 80t plus 96 minus, then plug in 2. So if I plugged in 2, I'd get negative 64 plus 160 plus 96 all over 2 minus 0. And then we can simplify this. So this would be the limit as t goes to 2 of negative 16t squared plus 80t. And that would be 96 minus 96, and then plus 64 minus 160, so that would be minus 96 all over, not 2 minus 0, t minus 0, t minus 2 actually. I'm writing that wrong in the denominator, I apologize. So t minus 2 and t minus 2. And so I can factor out a negative 16 from the numerator, and I would be left with t squared minus 5t plus 6, and then all over t minus 2. And then that would factor again. That would factor into t minus 3, t minus 2. And so the t minus 2's will reduce with each other. And so we have the limit as t goes to 2 of negative 16 times t minus 3. And if I plug in 2, I get 16 and then feet per second. So the instantaneous velocity after 2 seconds would be 16 feet per second. So that's how fast the ball is traveling at 2 seconds. It's traveling at 15 feet per second. When is the instantaneous velocity equal to 0? So we want to know when the instantaneous velocity is going to equal 0. So let's find the velocity anywhere, and the velocity anywhere is going to be the derivative. And so remember, the derivative function we can find by finding the limit as h goes to 0 of f of x plus h minus f of x all over h. And so my function was negative 16t squared, so this is going to be the limit as h goes to 0 of negative 16t squared plus 80t plus 96. So it's going to be negative 16, and then we're going to do t plus h squared plus 80t plus h plus 96, and then minus negative 16t squared plus 80t plus 96 all over h. And so if I multiply this out, I'd get the limit as h goes to 0 of negative 16t squared plus 2th plus h squared plus 80t plus 80h plus 96, then plus 16t squared minus 80t minus 96 all over h. And distribute that negative 16, so I would get negative 16t squared minus 32th minus 16h squared plus 80t plus 80h plus 96 plus 16t squared minus 80t minus 96 all over h. And then we've got terms that'll cancel. The 16t squareds will cancel, the 80t's will cancel, the 96's will cancel. And then we have the limit as h goes to 0 of negative 32th minus 16h squared plus 80h all over h. If I plug in 0, I'd get 0 over 0. So I can factor out an h from all of the numerators. And so negative 32t minus 16h plus 80 all over h. And now the h's will reduce. And we have the limit as h goes to 0 of negative 32t minus 16h plus 80. And if I plug in 0 for h, I'm left with negative 32t plus 80. So the velocity, or the derivative of my displacement, is going to be negative 32t plus 80. And so that's going to be my velocity equation. They want to know when the instantaneous velocity would equal 0. So you would say 0 equals negative 32t plus 80. And then we're going to solve. So we would subtract the 80 from both sides, and then divide both sides by negative 32. And so that would be 40 over 16, which is 20 over 8, which is 10 over 4, which is 5 over 2, so 2.5 seconds. So the velocity of the ball is going to be 0 at 2.5 seconds. That's also when the parabola is at its vertex. What is the instantaneous velocity of the ball as it passes the rooftop on the way down? Well, when it passes the rooftop on the way down, we already found that. That's at 5 seconds. So it's asking what is the velocity of the ball after 5 seconds? Well, we just found the velocity of the ball anywhere with this equation, negative 32t plus 80. So it wants to know the velocity of the ball at 5 seconds, because that's when it's going to pass the roof. So we're going to take negative 32 times 5 plus 80. And 32 times 5 would be 160. So this is going to be negative 160 plus 80, or it's going to be negative 80 feet per second. So that negative indicates the direction of movement. So that means that the ball is moving downward with a velocity of 80 feet per second. So that would be when the velocity, what the instantaneous velocity of the ball when it passes the rooftop, because that's at 5 seconds. What's the instantaneous velocity of the ball when it strikes the ground? Well, it strikes the ground at 6 seconds. So we want to find the velocity at 6 seconds. So we're going to take negative 32 times 6 plus 80. And 32 times 6 would be 192. So it's going to be negative 192 plus 80. So its velocity would be negative 112 feet per second. So that would be the velocity of the ball when it strikes the ground. All right, your homework is from 14.4. Let me know if you have any questions.